Hello everyone. In this lecture we will discuss about design of first net zero energy building of India, that is Indira Paryavarana Bhavan, New Delhi. So we will see the design strategies adopted in this building and how they have achieved actually this feat, which was actually a marvelous achievement in terms of creating the first net zero energy building of India. So the plot area, if you see, this has 9,565 square meters. So this is located in the bustling, actually, this Lodi colony, actually, area of New Delhi. And the site setbacks, if you see, it has like a 22-meter to protect actually front line tree line, preserve the integrity of the green street. So this is located next to this. You may have heard this. Lodi garden actually area, so it's in the vicinity of that area, so it's one of the most beautiful areas where there is an ample amount of like a greenery, trees, gardens, etc., and some like a historical heritage structures also. So this had actually the challenge of going with the theme and the language of this particular area. So yeah. So how they have actually first brought in the actually pedestrian movement on the site is shown through this illustration over here. So you can see this is the actually main street, and from here this is the entry to the main building, and these are the two different actually entries in the actually podium of the building from like two different sides. So we have this ground floor plan over here. So you can see this ground floor is a green actually area with the ample actually open spaces. So we see like a four actually these quarters of the these occupied actually building structures, and between these actually four we have these two actually crossing actually axis of this movement, and in this actually movement area there is an ample actually green cover and trees and other plants, and some water bodies are actually given over here for creating this ambient actually environment in this particular place. So you see based on the utility we have offices here on this side. Okay, we have recreation. These areas are of like recreation. We have this circulation area in the yellow, and then we have services in the like a blue shade. This is the actually basement. So we see the number of actually the parking actually facility for two-wheeler and four-wheelers are provided in the basement, so there is no actually ground level parking issue on the like a ground floor or outside the like a property on the like a main street. Further, another level of like a parking in the lower basement. Okay, so the first floor, if you see from there we can see this actually planning of the internal actually office areas and service areas and the circulation areas. So see, there is actually this connection which is established in these actually areas through this this actually a circulation area. On the top floor, this is taken from the like a terrace, so this is actually where the photovoltaic actually solar panels are actually laid on top of this building, so except the portions in a little bit in the like a setback, most of it is covering this entire actually the footprint of this building, and this is used for actually installing photovoltaic solar panels which actually generate electricity for the on-site consumption of the this building, as well as there is a surplus actually power generation also which is shared with the national grid. This is the elevation, so in this you can understand like how this elevation in the elevation it is clear that in the stepped fashion actually they have arranged these solar panels to maximize the actually solar gain on these actually panels depend from the actually the orientation. So you can see on this side, of course, this has to be like a north, and this side this is the south, to increase the actually the sun on these panels, and these panels are actually laid at these certain angles so that they can maximize the sun's intake. On the elevation you can understand there are jalis and other openings used, and they have like a terrace gardening also at different floors to actually enhance the ambient actually on this a premise. From the north side, which doesn't actually receives the direct sun, so the number of openings and the size of openings is comparatively wider. Okay, this is the cross section. So this is how this building is actually envisioned, utilizing the actually stack effect, to bring in the fresh air from the like lower floors and release the actually stale air from the like these actually roofings from the top. So this ventilation actually system is designed to work in the like fashion of like this vernacular architectural systems of like India. You see this the Sidi Said like this mosque jali from like Ahmedabad, the old Ahmedabad, so that is given over here. So this works as a, like an inspiration for like a creating like a jali the in the like a solid natural materials, which actually cools the air in like a climatic places such as like a which fall under like hot and dry and like humid areas. Okay, so this talks about devising the strategies for like a solar and like a water management. So you see like how this south side is utilized for these service areas which are not actually, there are no actually habitable or these spaces, and these gardens are like created at this lower floor, creating this like a green axis on this side, and some creepers are also utilized over here in order to lower the temperature of the air inside the like atriums over here. So and then water related services are all laid underground, so you see from here like this roof from the rooftop, this rainwater is getting collected in the rain harvesting tank. The surface runoff is also collected in this tank. They are actually sent to this HVAC absorption chillers for like lowering the temperature. Okay, and so this is how actually this water is also utilized, and the from this like you see like this supply of this gray water goes to the like a flushing actually water tank in the like a toilets, the from toilet it comes back again for use in the like a as a green water like a treatment over here, so and then from here the water is supplied for the like horticultural activities also, and they have actually this biodigester also in this underground in this actually premise, so the black water is received from like these places are collected over here, and further this solid waste composting is used for the, like a gardening purposes, and sludge is also sent for like a manure purposes and things like that. So there is actually complete cycle happening on this site, and this is one of the actually zero discharge buildings as you can see over here. So there is no actually discharge of water or the waste water from this actually premise. So it is not just helping on the like energy generation, it is helping on even actually in taking care of the other like natural elements also, such as like water. Further, this energy conservation measures are actually stated over here in this slide, so you can understand like how this cooling of this water is actually being done, so you can see over here this energy efficient lighting systems used in the top over here, reduction of artificial lighting load, because remaining lighting load supplied by building integrated photovoltaics, and see how the space frames are utilized for like laying the photovoltaic actually panels, and the water, if you see like how this water is utilized for the cooling towers, and heat exchangers in the air handling units over here, the chill beam is used for like the distribution across these actually sites, and then further it goes down in the like a ground, underground, and then again it cools, again it is like a taken up, and how this like a RCC like a light shelves with the reflective surface material are used over here for like reflecting the lights inside the inner like spaces. So this is where you can see like the number of applications for like a conservation of like energy and maximizing the actually use of the daylighting, in this building. Further, we have this like a some form of like a data over here, like what how much like energy is consumed, on what different activities, across the different these months you can see. So the largest one over the dark blue, the space cooling is utilized here in this month of like April, May, June, July, August till September, and for the heating, the January and December, and rest of the months it is like a ventilating like a fans, this purple color you can see over here, and the pumps and auxiliary are like almost like constant around the year, and then we have green like a various like a miscellaneous equipment, etc., and then yellow like for the lighting. So lighting also is increased in these months over here, in this. So this is actually a chart which depicts like what kind of like energy requirements are there in this building, and like a energy like a production and consumption. So this is a comparison like how like this building has performed in which month, so the only 3 months where the consumption has exceeded the energy actually production. You see this green bar to this reflect to that this purple bar. So the purple bar depicts the consumption, and this green one depicts the energy generation. So the energy generation relatively is lower in these months, so these are actually July, August, September. These are the cloudy months when there is like the overcast sky, and mostly like a rainy days. So the power actually generation has gone down, and rather like a dehumidification is also needed in like these months. These are actually months specifically for running like air conditioners. So the power consumption has relatively gone up. Rest of the months you can see the power generation is always like a above the consumption of the like electricity in this building. So I would like to give you some facts about this building. So the Indira Paranam Bhavan, New Delhi, this is a project of Ministry of Environment and Forest for construction of like a new office building in at like Aliganj Jorbag Road, New Delhi. The basic design concept of the project is to make the net zero energy green building. The building is targeted to achieve LEED India Platinum rating and GRIHA 5-star rating. The total cost of the project is estimated to be 128.63 crores Indian national rupees. Revised cost is projected to be 201.49 crores. Due to subsequent increase in the like a scope of work, the building in RCC frame structure with 3 basements and 2 blocks, one of ground plus 6, another of ground plus 7. Total plot area is 9,560.513 square meters. Basement area is 11,826 square meters. Superstructure area is 19,088 square meter, and total plinth area is 30,914 square meter. The building is planned to be a state-of-the-art landmark building with emphasis on conservation of natural areas and trees to reduce adverse environmental impact, provide adequate natural light, shaded landscape areas to reduce ambient temperature, maximize energy saving systems, and minimize operation cost by adopting green building concepts, conservation and optimization of water requirement, including reuse of water by recycling the wastewater, and also to make the building friendly to physically like a challenged like a persons. Many energy conservation measures are adopted to optimize the overall design load. High efficiency solar panels are planted to achieve net zero criteria. Energy efficient T5 and LED fixtures, innovative like a chill beam system for like cooling, pre-cooling of like a fresh air from toilet exhaust, using heat recovery wheel in order to reduce load on chiller plant. Water cooled chillers, double skin air handling units with various variable frequency drivers are planned to be installed. Geothermal heat exchange technology also planned for heat rejection from air conditioning system. And innovative energy saving regenerative lifts will be installed for the first time in governmental institutional building. Water conservation measure will be adopted in the building like low discharge water fixtures and dual flushing systems, low demand plants in landscaping, drip irrigation system for green areas, make up water tank for chiller plants, irrigation and rainwater harvesting system, which leads to saving in freshwater requirements. The mechanized car parking will be provided in this building for the first time in governmental office building to accommodate parking space for 344 cars. On the net zero like a design factor, well, this IPB building reduces energy requirement by 67% overall vis-a-vis like a conventional method. NS north-south orientation limiting WWR, insulation on wall and roof, extensive greenery to reduce heat load, maximizing daylighting to reduce lighting load, extremely low lighting power density 5 watts per square meter. Planning to minimize AC loads, keeping open atrium for like a cross ventilation, non-air conditioned lobbies. Efficient HVAC with the screw chillers, VFDs, chill beam, ground-based heat exchange for condenser, water remote computing, things like client servers. Energy efficient appliances like all 5-star B rated like appliances are used, and solar photovoltaic cells panels for the like a remaining load. This is an energy positive building, extra efficient imported solar photovoltaics SPVs, proposed terrace and projections 930 kilowatt, and energy produced by above is like in this range like a per year energy consumption for building per year, like it is in like this range. So you see like the consumption has increased a little bit, you know is always like under the like the energy produced. So the overall I think this building is falls under like a net zero energy surplus actually project. So performance parameters, if you see air conditioned load, is this much. Lighting power density load is here, electrical load is given over here. Okay, so let's talk about something about like a site planning. A plot measuring like a 9,565 square meters coveted out of like a 7.4 hectares of land for construction of this new office building. The land falls in Zone D of zonal plan. The land use of entire land as per MPD 2021 was residential and changed to government office for this piece of land. It is proposed to build a GPRA on balance portion of the land. The site is surrounded on east by NDMC housing and 15-meter row, on west by 12-meter row, and on the north Lodi colony, and 12-meter row on south GPRA colony of Aliganj. The plot is easily approachable from Aurobindo Mark and Lodi Road. The metro station Jorbagh is at walkable distance of about 300 meters from this place. Three-level underground parking is provided for 344 number of cars. It is state-of-the-art mechanized parking to cater central concentrated peak load during the office hours. Well, in the like a project scope, if you see, like it has like a initial scope and extended scope. It has like a 5-star rated green building covering the following: basic cost of structure with the this electrical installation, external development, 2 number like a capsule glass lifts, 4 number traditional passenger lifts, 1 goods lift, mechanized car parking for 344 cars, etc. So the this data you can refer over here. What it has like a catered in the extended scope, in addition of the above like a following, this net zero energy building with 930 kilowatt, this rooftop solar power plant, audio visual system in auditorium and committee rooms. So these are the actually features of which are under the scope of this project. On the materials front, ready mix concrete with the PPC having more than 30% fly ash content. Stone available in the nearby area for like a flooring is used. Terrazzo flooring with locally available stone materials, fly ash bricks, AAC blocks. Jute bamboo composite for door frames and shutters. UPVC windows with the hermetically like a sealed double using low heat transmittance index glass, double glazed glass. Use of high reflectance at terrace tiles for low heat ingress. Avoided aluminum as it has high embedded energy. Uh, Grass paver blocks for groundwater recharge. For the water efficiency, use of a curing compound, low discharge fixtures, dual flushing system, drip irrigation, use of native species of shrubs and trees having low water demand in landscaping, low lawn areas so as to reduce water demand, waste water treatment, reuse of treated water for irrigation and cooling towers of HVAC, rainwater harvesting. In the internal air, like indoor air quality, use of low VOC paints, no smoking zone, dust control, noise control is used. On the energy efficiency front, energy efficient lighting fittings are used which comply to the NBC code. Water cooled chillers, double skin air handling units are also used. So you see the details over here. This we have discussed in the previous like slides also. Innovation and design. So geothermal heat rejection, which will also help in water conservation in the cooling towers for the HVAC system, is used in this site. Chilled beam system for HVAC, regenerative lift, high efficiency solar panel to meet total energy demand, mechanized car parking to optimize on space and energy, low energy EM technology for biodigestion of organic waste, solar passive design to reduce heat ingress in building envelope and allowing lighting to over like a 75% of the indoor area. This is actually this Griha site visit due diligence 2 report. You can see over here. This is I have accessed from the website of this India Paranama Bhavan. It was available 2 years ago. So maybe you can refer this document for the detailed observation and report from like a Griha which was conducted on this building. So these images are a part of this report, like how they have observed the various actually activities on the site and they have reported. Okay, so with this we have come to the end of this lecture. Thank you everyone.